the other way of describing the electrons around a nucleus is to use electron configuration. And this is probably the preferred method because it's faster. Okay? And with orbital notation, you really do have to draw out each of the orbitals. So it's really good for understanding, but it's slow. All right? So here, with electron configuration, this is great because the lines and the arrows are eliminated. Instead, the number of electrons in a subshell are indicated by a superscript above the label. Okay? So let's take an example like oxygen. Okay? So oxygen has 8 electrons. Okay? And so let's do orbital notation, and then we'll take orbital notation to electron configuration. So why don't you pause it, draw the orbital notation, make sure that you get the same thing I did. It's a good chance to practice. Okay, there are 2 electrons in the 1s, there are 2 electrons in the 2s, and there are a whole bunch of electrons in the 2p. I put my 3 in, so that's 1, 2, 3, 4, 5, 6, 7. Now I need 1 more. That'll go right there. Okay, so now, instead of doing this, the electrons in a subshell, not an orbital, in a subshell, are indicated by a superscript. Okay, so in the 1s subshell, there are 2 electrons. In the 2s subshell, there are 2 electrons. And in the 2p subshell, there are 1, 2, 3, 4 electrons. Okay? And that's electron configurations at its most basic.